Hello, algebra students. Mr. Lawrence here, and today this is our second review video. This one will probably be a little bit shorter. We're talking about parallel and perpendicular lines. I'm breaking these up into a series of short videos so you can watch them and help you prepare for the final exam. Anyway, here we go. All right, remember, parallel and perpendicular lines have a special relationship. Please do not tell me parallel lines never cross. That is the elementary school definition of parallel lines. The high school definition is parallel lines have the same slope. Same slope. Perpendicular lines, their slopes are negative reciprocals of each other. So for example, if the slope equals 1/2, then the perpendicular slope is -2. Okay? In the top one, if the slope is 5, then the parallel slope is, you guessed it, 5. There we go. Now I've got 4 sets of lines here. I'm going to see if I can tell which ones are parallel and perpendicular before graphing them, because it's a lot of work to graph. Sometimes I don't want to. So the first thing I'm going to do is identify the slope. Well, on number 1, it's easy. The slope is 3/5. Now some of you are looking at this going, I don't remember how to do the slope B. Well, I say go back and watch video number 1, but do the ones that are easy. Let's do the slope here of 5/3. Oops, I should have made that poiple. Excuse me. Abracadabra, I make you poiple. There we go. Slope is 5/3. Now these are neither parallel nor perpendicular. They just intersect, right? Because it's not the negative reciprocal. It is the reciprocal, but not the negative. Now, if you watch the other video and you remember that the slope is found by doing negative of a over b, well, it looks like a is 3 and b is -5. So the slope is going to be -3 over -5, which is 3/5. Well, look at that. A and B are parallel to each other. So I'm going to do parallel, and that'll be lines A and B. They're parallel to each other. Now let me use the same technique to find the slope of this one. Looks like A is 10, B is 6. So the negative of A is -10 over 6. And of course I'm going to simplify that, divide by 2, and -5/3. Ooh, it looks like for perpendicular, okay, I'm going to have B is perpendicular to C, and line A is also perpendicular to C, right? Now, C and D don't have a relationship other than they intersect. That's it. No relationship. They're just friends. Okay, so let's graph them and you can see if I'm right. Now, A is in slope-intercept form, so I'm going to plot the y-intercept, which is -1. And then I'm going to rise 1, 2, 3, and run 1, 2, 3, 4, 5. There we go. And I'm ready to draw my line. 1, 2, 3, 1, 2, 3, 4, 5. So it's going to look something like this. I'm going to make him a little bit thinner because I think they look more accurate when they're thin and less bulky. All right. And we need some arrowheads on there, right? There's one, and there's one. And we want him to be blue. Oh, there we go. All right, now I need a red one. And let's see. It's in standard form. I can figure out the y-intercept really quick. It looks like the y-intercept is going to be 2. C divided by B. So the y-intercept is going to be 2. And the slope is 3/5. So it's going to go 1, 2, 3, 1, 2, 3, 4, 5. And look at that. You can tell it's going to be perfectly parallel. Sounds like a title of a good book. Perfectly parallel. The Guide to Imitating Successful People. There we go. I should write a book. All right, we'll make him red. We'll make him thinner. He went on a diet. And then we'll give him some arrowheads so he knows which direction he's going. Actually, he doesn't know because he's going 2 different directions. But that's beside the point. All right, the green one. the green one, the one we're saying is perpendicular, I got the slope. It looks like the y-intercept is 1, so it's going through this point right here. And the slope is down 5, 1, 2, 3, 4, 5, and then right 1, 2, 3. There we go. And let me get him going. 1, 2, 3, 4, 5, 1, 2, 3. Remember that old technique? I could go backwards as well, and I get the same line. Okay, confused myself for a second. Started going through the blue point. There we go. I'm sorry, the red point. I should be going through the blue one. But we figured it all out. We'll make him thinner. We need to be green. It's not easy being mean. Oh, I'm sorry, green. There we go. And there he is. And he sure looks perpendicular to the red and blue ones, doesn't he? Now let's go ahead and graph that Poiple one just for practice. Oop, that's not Poiple. There's my Poiple. All right, and it looks like I have the point for -2. Remember, I take the opposite sign. It's a -4. I put a +4. It's a +2, -2. So I'm going to plot the point for -2. 1, 2, 3, 4. 1, 2. There we go. And my slope is 5/3. 1, 2, 3, 4, 5. 1, 2, 3. And I could go 1, 2, 3, 4, 5, 1, 2, 3. And some of you are wondering, hey, is it going to be parallel? Or I mean, is it going to be perpendicular? No, it's not. I can tell by the slope that it cannot be. And you can see, sure enough, it's not. And let me change the color of him and all that good stuff. Let's see, properties. Let's make them thinner, make them Poiple, give them some arrowheads. And there we go. There is your line. So we found out algebraically that A and B were parallel, and graphically we see the red and blue one are parallel. And then we found that the green one, C, was perpendicular to both A and B, and sure enough, we get some nice right angles there because the slopes are negative reciprocals. 3/5 becomes -5/3. If the slope had been, say, 7, then the perpendicular slope would be -1/7, right? Okay, and then the purple one looked like a negative reciprocal, but it's not. It's only a reciprocal. So it doesn't have a special relationship to the other 3 lines. It'll just intersect. Remember, this purple one will keep going up like that, and therefore it will intersect all 3 lines, but not in any special way, not in a 90-degree way. Okay, so that's it for this video. Mr. Lawrence signing off. Have a good night, everybody.